Hello, sir.
Yes, hello. Hello.
Yes, sir.
Yes, yes, yes.
Sir, we cannot hear you. No. I think you are not connected with the audio. We can't hear you. We can see you. Sir, please check your headphone or try without headphone.
Yes, can you hear me now?
Yes, sir.
Yes.
Is it okay?
Yes.
Okay.
Okay, sir, there are many people in the waiting room. I'm adding them. And
Now can you hear me?
yes, sir, we can hear you. And we are live on YouTube as well.
Right.
So very good afternoon to everyone and a warm welcome to Adamas University Department of Geography. People are joining very fast and many people are joining. So I would like to request all of you to wait for another 4-5 minutes, then we will start our program.
Absolutely.
Okay. Can we start the program now? We have, I think, many participants have joined, and
Yes.
our speaker has also joined. So I think we can start the program. Once again, I welcome you to Adamas University Department of Geography. This is the 6th webinar under the banner of Future Geographer. And this series has started with a vision of providing the young geographers so this Future Geographer series was started with a vision of providing information about a particular theme of geography. Like it was started with providing information of geomorphology, then about disaster management. Someday we have discussed about oceanography. Someday we have discussed about paleoscience. So we are doing this to provide a detailed information about one particular branch of geography. What are the major research theme of that geography on which the young geographers are working, and how our students or the students who are interested in pursuing career in geography can follow the path, can have a fantastic career in those areas. So today we are very fortunate to have with us Dr. Bolen Basu, who is the Managing Director of Opsys System Private Limited and also is associated with Adamas University. We are very fortunate to have him, and he will be discussing about how the subject geoinformatics is transforming our life and how it is transforming the career opportunities of the geographers. Because geoinformatics, although it's a multidisciplinary subject, but geography students have an additional advantage of studying this because we used to study during the BSc and MSc courses, and it has become mandatory, and like all the geographical aspects of like geomorphology, human geography, everything has become dependent heavily on geoinformatics, on various softwares of geoinformatics, various approaches of geoinformatics. So this has changing the nature of geography and also creating massive job opportunities for the geographers. So without much delay, I would like to request my colleague Dr. Supratim Karmakar to take over this webinar and start the webinar and introduce the speaker to our audience.
Thank you, Kosturi. Today we are here on the 6th episode of the webinar series, and today we are going to focus on the geoinformatics, which is one of the major backbone for the geographers and all the practitioners who are related to these fields. And as we know that the geospatial technology is very much mandatory for the modern geographers for analyzing data and transforming, and those things are like transforming our regular lives. And this is one of the major and almost the most powerful decision-making tool which is emerging nowadays for any business or industries. And as it is allows to analysis of the environmental and demographic and topographic topics. So today we are very fortunate that we are having with us Dr. Bolen Basu, who has been experienced since 1996 in the field of GIS and remote sensing, and has been associated with Computing International, New Delhi, Rolta, India, PCI Geomatics, Canada, having MSc Tech, degree in Applied Geophysics with Remote Sensing as a special paper from Indian School of Mines, Dhanbad. He completed the doctorate program from Jadavpur University from the Department of Geological Sciences using GIS and remote sensing tools. He is the fellow of the Council of Scientific and Industrial Research, that is CSIR, and life member of Indian Society of Remote Sensing and Indian Society of Geomatics. He has national and international experience in this field of GIS and remote sensing, and has been trained in PCI Canada and has traveled worldwide on various occasions to participate in international seminars during his tenure in various organizations. So, sir, today we are really feeling very pleased and happy to have you with us. And so, without further delays, I would like to request you to deliver your lecture, and it will be, I think, it will be a very learning experience for us. So, over to you.
Thank you. Thank you, Professor Kasturi and Professor Supratim Karmakar for this opportunity to interact with you. It's my pleasure to interact with you all. So as I believe this house and audience which we have are mainly in the college level, and also some students who are going to enter the college. So that's an excellent opportunity to interact with the future generations on whom we are going to pass the baton. In few years' time, they will be all professionals. So I thank you and the university, and then what I'll do is I will move to share my screen, and at any point of time, please feel free to interact, anybody from the audience or from the coordinators. And roughly it would be around 1 hour, 1 hour, 15 minutes, and then questions as it comes. So fine, I just share my screen, and I once again welcome all the participants on behalf of the university, as they have rightly placed. There is a good opportunity, a Saturday evening. It won't be very taxing, I can assure you that. It would be an interesting areas where we would discuss a lot of things from the past to the future. So let's share my screen. Is the screen visible?
Yes, sir.
Great. So it's a very interesting topic, visualizing the world with geoinformatics. And should I speak louder, or is the voice okay?
Yes, sir. It's okay.
Is okay.
Okay, great. So visualizing the world with geoinformatics, that's an interesting topic, because when we say visualizing, it means something more than looking or seeing. It also applies to how we put our intelligence to what we see to interpret the things. So it's a very, very excellent topic. Our agenda, as I said, would be to take you through the series of developments that had happened with the knowledge of science that we gathered in our school days, how they are relevant with the subject and study that we are going to do in the future. We would definitely want all of you to be with geography, with geoinformatics, and I'm sure at the end of this session, you will see it is a combination of so many subjects. Geography being the backbone, still you have so many things at the background that will help us. The new horizons that embraces the geoinformatics, the industry requirements, career opportunities, whom are we going to compete if we have these, how are we getting ourselves aged, and then we would conclude. And so, as I said, I will take you through a bit of history of how developments happen. So before we go into any natural science or natural studies, understanding nature becomes a very, very important aspect of our understanding. So when we speak of science and technology, it derives inspiration from nature. All our senses, our perceptions, the medical science, you speak of any subject in science and it depended on nature. There is a saying like this: if a pine needle dropped in the forest, who would hear it first? Which animal? The elephant. Who would see it first? The eagle. Who would smell it first? The bear. What does it exactly mean? It means nature has provided the bear with some organs that can smell much beyond or better than other animals. It's 5 times better, for example, with the human things. So they hear a lot. The deer can hear a lot from far away. Similarly, eagles, we say the eagle's eye. So it's basically they can, what I would say, is they have a 20 divided by 5 vision. So we are having, if you see, what does this means from 5 feet away, the maximum that we can see is from 20 feet. What we see, they can, what we see from 5 feet, they can see from 20 feet. It's 5 times better, 4 times better than our vision. So that's how nature is. That's how nature is. And scientists are constantly trying to find out what mechanism is at the background so that they can see better, they can hear better, they can smell better. So 2/3 of the shark's brain is dedicated to smell, and it can detect the tiniest drop of blood from a mile away. So just imagine the amount of sensory perceptions nature has put into each animal for their safety, for their existence in the ecological balance. And now what the human being is trying to do is to take the best of all these animals, all the nature that has provided, and put it into a scientific domain so that we can harness out of it in a efficient manner for our better living, so that the next generations can live better, we can live better. So that's it. Imagine 500 years back, if I would or anybody would have said what is happening 200 miles away, you will be able to see. Nobody would have believed him. You will be able to hear. So out of the 5 senses that we have today, that we have deal with, out of that only 2 has been able to be transmitted. What is happening can be seen, what is happening can be heard. So hearing and seeing are there. So that science, there is a huge potential that in future, if you are taking a movie in the rose garden, you will be here, you will be able to smell it from in your television set. We are waiting for those days. So that's the nature study. Now I take you to something more that we have already learned in our school days life. Let's look back. The very first name that comes to us is Sir Isaac Newton, and we all know that gravity, the falling apple story, and things like that. But what we miss out sometimes is what exactly is gravity related with geography, where it is matching. We have learned up to class 10, 12, all these things. And you must have heard about another scientist named Galileo. You must have seen in the history books about the Leaning Tower of Pisa. So I will just take you slightly to refresh about what we had learned in our school days. So when Newton said that Earth has a huge potential to pull down things, it was a huge discovery at that point of time. Nobody knew it. But at the same time, if you try to drop a coin and a feather, who would fall first? Your obvious answer is the coin. The feather will come much later because the coin is very heavy. Interestingly, the situation is not like that. The Mother Earth pulls both of them with equal force. So if this is the picture you must have seen in your science books and graduates, that if this is a vacuum, a bottle, and you release a coin and a feather, both of them will simultaneously come down at the same speed, because the pull or the force of the earth is same on both of these objects. This is something interesting. This is something which is related with us. So the earth pulls all the objects equally. It is because of the shape, because of the air friction, because of other stuff, one appears to fall faster, one appears to fall slower. But it's not like that. Both of them will fall same if it is in a vacuum. Now you must be wondering, what has this to do with gravity? What has this to do with our geography? That is what I bring in. There are different shapes and objects below the Earth surface. Some may be of higher density, some may be of lower density, some may be of different shapes. And if you put a cloth on all these objects, you will have a white line like this, which you call the topography. But all these objects have variable densities. 200 years back, when they said Mother Earth cools equally, we all learned in our physics that it is acceleration due to gravity, 9.8 meters per second and stuff like that. But here is where the modern science has slightly changed. What it has done is, it is more or less equal, but not exactly equal. This object will pull the body in a little bit different way. This will pull in a different way. This will pull in a different way. Just 60 to 70 years back, this discovery was done. That the gravity pull is dependent on the density below the Earth surface, and that what defines the Earth surface. So now we understand that what we learned as acceleration due to gravity and the pull of the Earth and stuff like that are because of objects below the Earth surface that is causing this topography to be what we see as like this. Now, what is this? If we can calculate the gravity values, we can calculate the pull at each place, at your place, at Calcutta, at Midnapur, at Howrah, at Hooghly, whichever places. If you can calculate the pull of the Earth and give me the values, I can give you the shape of the Earth. So the modern day geographers and the scientists, how they are defining how an asteroid shape is. Nobody is going there to take photograph of the asteroid. What they are doing is, by help of modern day satellites and instruments, they are basically trying to calculate the gravity value at the surface of that asteroid, the gravity value of that planet. And using those gravity values, they are defining the shape of the object, mainly the asteroids, which are very near to us, because they are very irregular shape, and we need to know the shape before we send a mission over there. Because why we need to send a mission? It is a huge source of minerals. So if we can scoop out little minerals from them, our problem of energy will be solved. That's how Isaac Newton's discovery of the simple gravity has brought us to today's technology of satellites measuring gravity to give the shape of the objects in the space. So that's very interesting. Now, in the earlier days, we all knew about light, that which we can see. For the first time, there is something invisible which is existing in nature that came out. So there was a German scientist or physicist who was named as Röntgen. He was working on some other objects. He was working on some other subject. And very interestingly, he noticed something very strange. He observed that there is some rays which he could not see, but it is existing somewhere near his instrument. What he told his wife, can you please give me your hand? I would like to place your hand on this instrument. And then there was a photographic plate. After some time, he could see the skeleton of the hand of his wife, and this is the ring of the wife. At that point of time, he could not explain what he had discovered. So he named it as X-ray. as we do in algebra. What is the age of the father? Let his age be X. So based on that simple thing, he named it X-ray. And that's the reason at that point of time, he didn't know what it happened, but that was the part of what we call today's technology of the remote sensing. That means without physically touching, seeing, if you can decipher, you can find out some information about the object. That is what we call as remote sensing. You cannot see the skeleton and the bones inside your body, but somebody else did it for you, and you are able to see where the crack is, where the joint is. So this is remote sensing. So the medical people, doctors started using it. Natural scientists came much later. So the invisible rays, the Röntgen rays, the X-rays, we call it as the first invisible rays that gave birth to what we call as X-ray. Now, all of you know about electricity, all of you know about magnetism. But there was again a group of scientists who was trying to work out something between these two, whether they are related or not. How do they relate? Electricity was developed in a separate way, magnetic energy, magnets, they were differently developed. At one point of time, this Dr. Faraday, Dr. Michael Faraday, he did a very interesting experiment. He put a cable near a coil of the wire. I would show you this. I think that would be easier to understand. He just pulled a magnet inside an electrical coil. And the moment he took the magnet near the coil, the bulb was getting lighted. The bulb was getting lighted. So this gave birth to something which we call as so when he discovered this, that when I am taking a magnet inside the coil, electricity was generating, people were laughing at him. Scientists were laughing at him. What good is that? One of the public asked him in a talk when he was demonstrating this experiment. He said a very good thing. He said, when a baby is born, do you do you know whether he will become a doctor, a professor, geographer, civil engineer? You don't know that. You nurture him, you educate him, you try to build his potential, his passion, and then you develop that gentleman or gentlewoman into a good citizen of the country. So similarly, I have given you something, work on it, try to find out what it can give you. And when you actually enter into the world of GIS, remote sensing, satellites, the very basic structure of the whole science of remote sensing is based on the relationship between these two energy fields, electrical energy and the magnetic energy. I give you a very small example. Everybody of you know electrical motors, the motors like fans, the car that you are riding. He came to a conclusion that if electricity and magnetism are existing, motion is created. Three things: electricity, magnetism, motion. You give me any two, the third will be generated. You have observed people working on generators, pulling a string, moving a handle like this. So there is motion. There is magnets inside the generators. Electricity is generated. So he was the pioneer of these scientific developments which showed us if electricity is there, if motion is there, current will be generated. If current is there, magnet is there, motion will be generated. That opened up the Pandora's box of developments of the whole world. What we see today, what we see today are basically the relationship between these electricity and magnetism that has given birth to a lot of instruments which is based on this. So the electromagnetic theory was born. So he is given the credit of first introducing this relationship between the electricity and magnetism that exists in nature, how he could not explain, but at the same time, he could just tell us that yes, it is existing in nature. And what you see in the books today, like this, the spectrum from V to R, then the infrared, then the radio waves, ultraviolet, X-rays, and you put it in a sequence like this, coming from the radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, gamma rays, is because he introduced this concept that electricity and magnetism are somehow related. That gave birth to something very, very interesting. The moment that was discovered, the other group of scientists were trying to find out whether sunlight is able to ignite an object so that it can release light. Where if sunlight falls on sand, does it release any energy? Does it release any light from there? Because it can always do. We cannot see invisible, so it can come. And it was not reflection. Remember, reflection is a very simple thing. Light falling on the object coming to your eyes. No, they were looking into something. If it falls on the object, will it release something that we cannot see? This was the question that came to the mind. And this gentleman, Dr. Becquerel, he was researching whether sunlight could make uranium emit X-rays or not. So he went outside his laboratory and he was waiting for the sun. Unfortunately, on that particular day, it was very cloudy. So he tucked the whole equipment and came back to the room. The next day, when he opened, he found something very, very exciting. He found out from this object, something was automatically coming out in spite of there was no sunlight. So it was automatic. It was automatic. Yet he discovered what we call today as radioactivity. That means there are certain objects in nature, even if you don't do anything to them, they will begin to emit energy of its own. This concept of understanding gave rise to what we call as nuclear science. Today's seed of nuclear science was basically by an accident, you can say, as you can see, that he was trying to experiment whether sunlight can excite the objects to come out with energy or not. And in the end, he discovered that even there is no sunlight, there are certain objects which can give out radiation. That is known as a radioactive element. And we are very afraid of radioactivity activities. That's why nuclear missions all over the country, the atom bombs, the activities, the researchers behind it have to be very secure, have to be very in the good hands. So that is where the science has dropped in. So I would say Becquerel could not solve the question, but he discovered the seed of nuclear science. And then there was the grand entry of Sir Albert Einstein. You have all heard about his name. If I ask you why he won the Nobel Prize, 80% of the students would say he won Nobel Prize because of his theory of relativity. We don't know much about his theory of relativity. It is a very, very complex subject, but at that much we know that he explained everything is relative. When you are sitting with your friends, 1 hour seems like 5 minutes. When you are sitting inside a boring class, you know what happens. So 40 minutes appears like 2 hours. So everything is relative in this world. He put it in some other mathematical forms. But Einstein did not receive Nobel Prize because of his theory of relativity. We will come to it. Einstein received his Nobel Prize because of something very, very exciting. That which Becquerel failed, the last slide which I showed, when sunlight falls on the object, yes, it does excite the objects. And these objects releases some sort of energy packets that goes out inside from the objects. So just imagine soil. When sunlight falls on the soil particle, they have some amount of interaction and energy packet is released from the soil, from the sand, from the tea leaves, from the vegetations, from everywhere. The moment sunlight falls on them, something happens inside it which nobody knows, but it releases energy packets. And these energy packets, when they are released, are captured by the satellites. That came at a much, much later stage. Some 20, 25 years later, after he discovered all these things. So Einstein, we know, is famous for his theory of relativity, but he won the Nobel Prize, which is giving us our today's subject of satellite remote sensing. This is the bedrock of today's satellite remote sensing evolved. And this is completely a philosophical innovation, which was proved later mathematically, but this philosophy came to him that it can happen in this way also from his former studies. How interesting this science has begun to develop. Now, we all heard about frequency, wavelength in our class 10 physics, science, and all these things. So this is just again a backdrop of the pictures that you had seen in your science book. But our question is, who is more fundamental, frequency or wavelength? For those who of you already know that frequency and wavelength are interrelated, if you know the wavelength, you know the frequency, how they are different. No. Interestingly, that is also another invention, that frequency is more fundamental in nature. What does it mean? Basically, what does it mean? It means when light goes through a medium, for example, water bodies, when you are throwing a red light or a blue light, it has both wavelength and frequencies. This wavelength will change, but the frequency will never change. This is a big, big invention made by the scientists. So light has both wavelength and frequency. However, when light enters into the atmospheric medium, water, the speed slightly comes down because it is getting a resistance. So if it comes down, who is going to compromise? Frequency has to come down or wavelength has to come down? Frequency will never change itself. It is the wavelength that comes down. It is like wearing a white shirt. You are the same person. When you get into a very busy road, your shirt becomes dark. So your shirt compromises. It becomes slightly less white, but the inner self, your body remains as it is. Your body is the frequency, the shirt is the wavelength. So this is a very big development in nature. How do you understand that it is the light frequency is fundamental? I have given this example. There is a red pen which is dipped inside water. So from this red pen, the ray is coming to your eyes, passing through the water. Had this wavelength changed, this pen would not look red. It would have been a different color, but it still looks red because It is the frequency that you are looking, and frequency does not change. So we see frequency of light. This basic understanding changed the whole concept of satellites. So satellites, when they were sent, they were capturing energy of the light. Light is an energy, we all know. Energy is related to frequency, and frequency is related to the object. Leaf will have a different frequency of light. Sand will have a different frequency of light. So the satellite captures energy of light. Energy is related to frequency. Again, frequency is related to object. So in other words, by logic, satellite is related to object. So this is what you see in your Google Maps. So the satellites have picked up the light, picked up the frequencies, and from the frequencies, you are able to understand the object. This is road, this is water body, this is that, this is building, etc., etc. But at the background, 200 years of science have given the scientists these background studies to evolve in a very, very systematic manner. So that is how we are going to see, we are reaping the benefits of the scientific developments done for our applications of natural resource studies. Einstein and GPS. We all know GPS, you all know, must have used it in your mobile or in the instrument, which is a global positioning system. One could hardly imagine a branch of such a fundamental physics, which is the theory of relativity, is related with something that we use in our day-to-day lives. Had Einstein not developed this theory, today we would not have GPS. And just imagine the pain that we would have for that. Now, what is theory of relativity? Theory of relativity says the speed of light is the only constant thing in the world. Everything else is relative. So it is very easy to understand everything is relative, but the most difficult concept people have today to understand that time is also relative. The example I told you, time is really relative. Long hours of winter, people say, শীতকালে মনে হয় 1 ঘন্টা is slightly longer than the 1 hour in the summer time. Really it is so. When you are in front with your friends, 1 hour seems 5 minutes. When you are seeing a boring lecture, 5 minutes seems 1 hour. So everything in this world is relative. The perception varies. This is proved mathematically. And there is a very good example, I would say. If two twins are there and one is in the earth and the other is sent in the space, after 5 years, the twin who is in the earth will be aged by 5 years, but the one who is coming back from the space will be 4 years, 8 months. He won't be 5 years. So if you are given a sufficient speed to something, your mass can change, your time can change. We are not getting into that complexity. We will just try to understand the GPS that you see, why it is complex. The satellite is moving at 14,000 kilometers per hour. Einstein said and proved that if it is moving at 14,000 kilometers per hour, then in a day, 7 microseconds would be the loss in time. It will be slower by 7 microseconds. So the Earth clock and the clock in the satellite, they won't be the same. The clock in the satellite will be slower by 7 microseconds. Very good. We have understood it. He has proved mathematically, so we have nothing to say. Now the satellite is 20,000 kilometers above the Earth's surface, where the gravity is very less. He again said if the gravity is less, this time the clock will work faster. So because of the speed, it will be slower. Because of its height above the Earth's surface, it will be faster by 45 microseconds per day. See the complexity. So effectively what happens, the net result is that the GPS satellite actually differs by 38 microseconds per day with respect to Earth, because the Earth is moving, the satellites are moving, huge speed, so everything is relative. Using this technology, somebody has found out that we could use it in our day-to-day lives to find out my position on the earth, because it is just signals. They are being sent, how much time it takes, how much this, that complexity we are not doing, but we are just trying to share with you that it is the technology of this theory that has given us such a fantastic tool like the GPS and a number of things like that. All survey instruments which is based on this technology would not have come had we not have had the theory of relativity. Now we are slightly moving ahead. What is remote sensing and image processing? We all hear about this term. So remote sensing, by this time, I have explained to you, it is the technology by which you understand objects without seeing. Doctor tries to understand our pulse rate, the heartbeats, etc., without physically touching the heart. And image processing basically is trying to interpret the result brought in by this remote sensing technology. So what the satellite gives you is just informations of the emissions, which Einstein explained. And you are studying the emissions to find out whether it is a rock, whether it is a water body, whether it is a plantation, whether it is vegetation. It is your job, our job to interpret that, and that is known as image processing. By this time, this tree, these two gentlemen, rock, forest, you have seen with your eyes, that is remote sensing. If you have observed, there is a fetus over here, see the legs, this is the nose, eyes. What you have interpreted is called image processing. And what the professors were trying to tell you, this subject of GIS and geospatial technology has given a quantum lift to our subject of geography and other natural resource studies to a new height, wherein the engineers and the geographers are working together to contribute to this science of geospatial technology. You see the list of professionals who are engaged into this domain. We will have to sit side by side with all different domain knowledge people to contribute to this technology of human activities. So it's a very, very interesting area. Agriculture and GIS have come up in such a big way. Just imagine there are over 25 big Indian companies who have a GIS cell of their own, and they are
with precision agriculture, farmers need to know precisely what inputs are needed where, in what amount, and when. This requires collecting a lot of information from different sources and in different parts of the field on things like soil nutrients, the presence of pests and weeds, the level of greenness of the plants, inputs applied, and the weather forecast. Once collected, this information needs to be analyzed to produce agronomic recommendations. For instance, given the developmental stage of a plant, its level of greenness may reveal its nutritional needs. This information, combined with the characteristics of the soil where the plant is located and a forecast of the weather, can be used to determine how much of a certain fertilizer should be applied to that plant the next day. Delivering agronomic recommendations on time to farmers and ensuring they are able to apply these recommendations is key. Farmers need to have all the necessary inputs at hand and be able to translate the recommendations into actions in the field. To solve this problem, big farmers use sophisticated machinery that collects georeferenced information on soil characteristics, yields, and greenness of the plants. These machines are often connected to the internet and send the information automatically to ag big data firms that analyze the information and send agronomic instructions back to the machines, which are able to automatically apply them in the field. For instance, using robotic devices attached to GPS-guided tractors. However, solutions like
So just imagine this type of technology which is now coming over here, and these are the Indian companies. So there's a whole lot of Indian companies who have an individual GIS laboratory, which was unimaginable even 10 years back. This is the utility sectors, which is again recruiting a lot of people with the knowledge of geography and geoinformatics. These are the name of the companies. So if I show you the various applications again, the subsurface
Competing in today's energy sector means addressing constant change and disruption. Modern utilities need to keep up with multi-directional power flow, distributed energy resources, and the explosion of connected devices, generating massive amounts of data. Traditional siloed departments and systems are no longer sufficient. In this new environment, utilities need to have access to data across the enterprise and harness valuable insights from all systems. A network-based geospatial information system, or GIS, is the key to both achieving real-time data access and creating an intelligent ecosystem that can simulate grid dynamics. GIS providers are waking up to the need for a network-based platform, but evolving existing solutions is tough and expensive. Utilities can offset the cost and challenges of modernizing their legacy GIS systems by turning to a proven network-based GIS provider. GE's Small World technology uniquely combines over 25 years of experience with network modeling, real-time control systems, and large-scale data historical service and operational data. Utilities can better predict.
So we understand how it is being used currently. These are the companies which are recruiting people like us, like you, will be equipped with the knowledge of geography and geoinformatics, and contributing to these solutions. Survey is a big area which has come up in the last 5 to 7 years, which they are using GIS to huge extent, And what I have given are all the GIS, are all the survey companies using GIS. These are simple applications which you see how they are opening up with respect to the map to represent their properties, using satellite images to show where it is located, how high it is compared, what is the location, utilities are present or not. So if you have to convince somebody about selling our residential complex, office complex, they need to answer a lot of questions. And these questions are being answered by this type of technologies. Drone, which you see during the crowd management and disaster, is only one part of the story. The other part of the story is related with the development of the three-dimensional information of the Earth using drones. So you must all have heard about the aerial photography where the planes used to fly with images. The same thing is done by drones at a very insignificant cost. So naturally, once that is over there, you can find out in 3D the utility of the Earth's surface over there.
3D models with drones and how these 3D models are being used across different industries. First, what is a 3D model? It's a 3D model manually by using 3D modeling
This is all
software.
done by software.
Photogrammetry
so really
is the science of making
this.
measurements from photographs. Particular photos you have of your subject taken from different locations, the more accurate this triangulation process will be. The result is accurate point locations plotted in 3D space. which is exactly what you need to create a 3D model. Drone photos are great for this process because every photo is geotagged. This means the latitude, longitude, and altitude from the drone's GPS and onboard sensors are embedded in the metadata of the image. The metadata also includes information about the camera sensor and the optics of the drone. These geotagged photos can be processed by software programs such as Drone Deploy, X4D, and X4D Capture, allow you to create automated flight paths and set your desired image overlap. The second thing you need to do is make sure you capture photos of your subject at different angles and altitudes. Typically, you want to capture straight down images from around 100 to 200 feet. Then you want to circle your subject at a high altitude with about a 30-degree angle. Next, fly at a middle altitude with a ramp. The construction industry has seen a huge benefit from drone imagery, mapping, and 3D modeling software. Construction firms can monitor progress of their construction sites with regular updates, and they can easily inspect different areas on the site. The accuracy of the 3D models also means they can be used to calculate distance, area, and volume measurements. Land surveying has also seen tremendous benefits from drone technology. Not only has it gotten easier to get an up-to-date view of a landscape, 3D models, add annotations, and see the original imagery for a better look at a particular area. Energy firms benefit from these kinds of tools as well. Much of their equipment is larger, more dangerous, or in challenging to reach locations. The ease of inspecting equipment with drones and 3D models can help make sure inspections happen more frequently, reach more dangerous or challenging to reach locations, and help ensure the safety and longevity of the equipment. The agriculture industry is another area where drones are transforming the landscape. While farmers are not necessarily using 3D models, they can still leverage data from drones to create orthomosaic maps of their fields. Newer drones are available with multispectral cameras, allowing farmers to create normalized difference vegetation indexes for a deeper understanding of their crop health and field performance. Public safety can also utilize 3D models for documenting and recreating crime scenes, recording evidence, and providing a clear picture for investigators, forensics, and jury members. Officials can even gather imagery and data in the wake of natural disasters in areas typically unsafe for people. And finally, architecture and engineering firms are using 3D models to create detailed and realistic context models of their buildings or development projects. These models help architects communicate their final design to key stakeholders and investors. And across all of these industries, drones are making it safer, faster, and more efficient to gather meaningful data while reducing liability and risk. Check out our article linked in.
So this is a very, very important developments which has come up in this domain of geoinformatics with people with the knowledge of GIS, geography, and stuff like that. They are
light
using
detection
this
and
technology
ranging.
for the development.
Though LiDAR is used in a number of applications, we have chosen the top 5 areas where LiDAR plays an important role. Autonomous vehicles. If you've seen a self-driving car before, you've probably seen a LiDAR sensor. LiDAR works as an eye of autonomous vehicles. Imagine it.
So you must, if you know, when you see a very updated Google map, be assured somebody just 6 months back have taken a LiDAR information on the vehicle. They have put this LiDAR and the vehicles go across Park Street, this, that, road, anywhere. And the other surveys have gone at the background and they are updated at least once in a year. So that's how the technology is changing.
If your human eyes allow you to see in all directions all of the time. Imagine if, instead of guessing, you could always know the precise distance of objects in relation to you. LiDAR enables a self-driving car to view the surroundings with a few special superpowers. Agriculture. LiDAR can be used to create 3D elevation maps of a particular land, which can measure underwater and helps create 3D model of the terrain. Underwater information of a river can help understand the depth, matter, which are the same size or larger than the wavelength. For archaeology and builder technology can be used. It is very useful for maintaining a record of the structure.
So the whole idea is to share with you that we are dealing with some fringe technologies which are up to date and needs to have knowledge of this type of backgrounds to use them which is what makes this technology an encompassing one. It encompasses various domains, which makes it more. Now, environment is a big subject, and you are worried about why we do this environmental, why are we so calling environment? So if you compare the art history with the calendar year, then the modern humans have come for the last 37 minutes only, roughly 6,000 years. And 1/3 of the Earth's natural resource have been used in the last 0.2 seconds. So imagine what has happened to our Mother Earth. You cannot escape it. We cannot just simply sit idle. We have to use nature and exploit nature, but we must be cautious about how we use or exploit nature. So this is the reason of such concerns, where we need to scientifically exploit things so that we do not pose danger to the next generation. In this, I would take 2 minutes to give you an example of the Yellowstone National Park, where the wolves changed the course of the rivers. Just have a look at this. It will be an interesting insight into an environmental program which was considered to be a very successful one. A wolves changed rivers.
Findings of the past half-century has been the discovery of widespread trophic cascades. A trophic cascade is an ecological process which starts at the top of the food chain and tumbles all the way down to the bottom. And the classic example is what happened in the Yellowstone National Park in the United States when wolves were reintroduced in 1995. Now, we all know that wolves kill various species of animals, but perhaps we're slightly less aware that they give life to many others. Before the wolves turned up, they'd been absent for 70 years, but the numbers of deer, because there was nothing to hunt them, had built up and built up in the Yellowstone Park, and despite efforts by humans to control them, they'd managed to reduce much of the vegetation there to almost nothing. They'd just grazed it away. But as soon as the wolves arrived, even though they were few in number, they started to have the most remarkable effects. First, of course, they killed some of the deer, but that wasn't the major thing. Much more significantly, they radically changed the behavior of the deer. The deer started avoiding certain parts of the park, the places where they could be trapped most easily, particularly the valleys and the gorges. And immediately, those places started to regenerate. In some areas, the height of the trees quintupled in just 6 years. Bare valley sides quickly became forests of aspen and willow and cottonwood. As soon as that happened, birds started moving in. The number of songbirds, the migratory birds, started to increase greatly. The number of beavers started to increase because beavers like to eat the trees. And beavers, like wolves, are ecosystem engineers. They create niches for other species. And the dams they built in the rivers provided habitats for otters and muskrats and ducks and fish and reptiles and amphibians. The wolves killed coyotes. And as a result of that, the number of rabbits and mice began to rise, which meant more hawks, more weasels, more foxes, more badgers. Ravens and bald eagles came down to feed on the carrion that the wolves had left. Bears fed on it too, and their population began to rise as well, partly also because there were more berries growing on the regenerating shrubs. And the bears reinforced the impact of the wolves by killing some of the calves of the deer. More riffle sections, all of which were great for wildlife habitats, the rivers changed in response to the wolves. And the reason was that the regenerating forests stabilized the banks so that they collapsed less often, so that the rivers became more fixed in their course. Similarly, by driving the deer out of some places and the vegetation recovering on the valley sides, there was less soil erosion because the vegetation stabilized that as well. So the wolves, small in number, transformed not just the ecosystem of the Yellowstone National Park, this huge area of land, but also its physical geography.
So you could see that the deers were finishing off the vegetation like anything. The introduction of wolves changed their places, and then how the ecology began to revive. That's a very interesting case study about how the environmental impact assessment can be done. I was speaking of asteroid mining, so this is in place. The scientists have already, Astra is our nearest asteroid. It has been mapped by using the gravity values, and now they are trying to scoop up. 2045 is the target year, which is where they will go down to the asteroid and pick up a bit of uranium from there. So the career options with geography and knowledge of informatics or GIS, you have to look out with this type of job postings, and day by day it is increasing, more so of the introduction of various other domains in the private sector, which has made it more interesting. So it is there. This slide is slightly important. In India, the career opportunities of the recruitment studies, profile studies have shown that 14% with the knowledge and background of geography are recruited in this domain of GIS and remote sensing. And with the knowledge of GIS and cartography, it goes to 26%. So if you combine 14 and 26, it becomes 40. The computer science is dominating these recruitment with 29%. So with geography and GIS knowledge, we are slightly ahead with the computer science. We can more effectively fight with the computer science domain, quickly followed by engineering domains, the civil, electrical, architecture. This is the profile of all the recruitment that has happened in the last 5 years in the various companies and has been recorded. So the crux of the message is with geography as a background or as the natural studies backdrop. If we can have a course done on GIS and cartography or geoinformatics, the percentage, the scope increases manifold, and it brings at par with almost with the computer science and engineering people. Now, to do that, what we really need to have is this one. These are the self-explanatory. You need to have a knowledge of statistics a bit, GPS a bit, AutoCAD, general GIS, database, programming skills. If you can develop, to take you a long way, but the application software still dominates. It can be any software. Trust me, we have seen people, it is not just this software, that software, this software, we have come out of that. You need to be knowledgeable, and if you get 5 days, you can learn any software. So that's not a big deal. So understanding the technology through QGIS or any open source or any software, if you know the knowledge, knowing a software is just a matter of 5 days. But this is where the skill development plays a big role. The theoretical knowledge behind it, why you are doing it, that plays a role. With that, we are slowly coming to our conclusion that what I have been trying to do and share with you is the historical background by which we see today's science of remote sensing and GIS as we see today has been starting from the days of Newton, and those basic developments are taken into our subjects to give it a different dimension. So the meaning and value of geographical information system is expanding. We have to keep our eyes and ears open. We are moving towards hybridizations. 25 years back in our days, simple, okay, I did this, I did that, engineering or medical or a degree or something. It was more streamlined. Now, the more hybrid knowledge one has, the more age he or she gets in the success stories. Diverse verticals are embracing this technology. I had the opportunity to work with medical professionals, at least 50 medical professionals in and around Calcutta who took a course on GIS. On the other spectrum is the defense. So, and the conventional spectrum of architecture and conventional mapping organizations like NATLO, GSI, they are already there. But just the whole idea is the people from the newsprint, it would be, it's very encouraging. Organizations who put hoardings and advertisements, they need to see the location so that it is accessible and viewable from most of the parts. So which is the area they should put a hoarding so that it is visible from maximum area. So they are taking help of the GIS. Electronics and telecommunication people, where there is less 4G customers, more of 2G still happening, where we need to put more of towers so that we can expect in comparison with the demography of that place where we are lagging behind with the competitors, Airtel falling behind Vodafone or vice versa. So that type of studies are coming up in a big way. It is happening. Communication skill is very much important. Ultimately, at the end of the day, you should be able to convince somebody that you should use this for your own good. So that requires not only knowledge base, but also some sort of communication skill. So it is my honest suggestions to all of you, apart from the basic skills and knowledge that you are gathering, you should also look out for developing this communication skill, which needs to be managed. I would like to end with saying that the future depends on what you do today. 10 years down the line will be defined by how you are spending your time today. Don't compromise anything, but at the same time, you must also have fun in learning, So with that, I would look forward to your questions. I would try to, with that, I would like to stop at this point.
Thank you, sir.
Took you through the domain from
very elaborate and very interesting lecture it was, like, especially with the videos you have shared. Sir, we have one question from
Yes.
Udita Bhattacharya. She wants to know that, sir, can you explain once more that how Einstein and GPS is related to each other?
Right, right. And Einstein's theory of relativity was basically trying to show us that time is relative. Time is relative in the sense what you see as 1 hour is not the same as duration as you are in the space. So when the satellites are moving and they are trying to position ourselves, they are sending signals to the Earth. Now, these signals takes certain amount of time, let us say 2 seconds. So by your watch, the signal which you see as 2 seconds is actually not 2 seconds. There is 1.83 seconds. So how or why it happens? It is because of the mathematical formulation by Einstein. And if we can precisely measure the time, you will be able to precisely know your position of latitude and longitude. Otherwise, you will fail to know your latitude, longitude precisely. That's the reason. Theory of relativity is a big subject, which we also don't know in the details, the mathematics behind it, but broadly in a common language, that's it.
So there is another question from Onkita Roy.
Yes.
She's asking, will mining asteroids cause pollution in space?
Asteroids, we have no hand because it's natural. The problem is with the space debris, that 20,000 satellites over the past 50 years that we have sent from various countries. When they become defunct, they are the debris in the space. And one news that went unnoticed just 6 months back, there was a collision between US and Russian satellites. Most probably it was a spy satellite, otherwise they would have already published it. So this problem of space debris is a concern, but asteroids I don't think is a big concern in terms of pollution. We have no hand on it.
Okay, sir. So,
There is no other question,
no
but
other questions.
the session was really interesting. That participants are saying, and we are saying on YouTube as well. Thank you so much, sir.
Thank
So, if we would like to request if participants have any more questions, 1 or 2 minutes, we can. Yes, one raise hand. Yeah.
Yes.
If I'm allowed, Meera, can I ask one question?
Yes, yes.
Yeah, most welcome.
Thank you, sir. First of all, it was a really a wonderful presentation. Like it's
Thank you so
again
much.
has reminded us our remote sensing class, and it was really very interesting, sir.
Thank you so
So I would
much.
just like to know one like basic questions that we face from our students, and even when we go for the like placements and all those things when we are working. So many companies they are recruiting geographers. I know that they are recruiting geographers. However, they have some prerequisition and some predefined criteria, some predefined skills outside the geographical degrees. So can you sir just like little bit elaborate on that point as well? So
Yes,
that
sure, sure. Most of the companies, there is a huge resources which are available free. For example, Google Earth Engine is a very good example, which we can harness in terms of using the database which is already available to give it to the industry at a very low cost. Or maybe we would not like to invest much in this. How do we get data from these different sources? So the industry, apart from knowledge in the domain of GIS and remote sensing, generally would like to have a more wider aspect in terms of domain knowledges on the survey a bit, how LiDAR works. If I get a LiDAR data, can you take me to the GIS environment? Can you put it to the 3D CAD environment? These are very small things, but this is the requirement which we face from the students in the industry. So I think the type of syllabus that we discussed in one of the sessions, Adamus has a very good exposure to these technologies in the professional courses which are also coming, and in the conventional courses. It's in the right direction. But yes, as you rightly pointed out, apart from geography, a bit of knowledge on uh, the survey components and the development components, like Java, a little bit of programming technologies with Python, which we can use it to build some new things. That gives an edge. Uh, Definitely, that gives an edge.
thank you very much, sir. I think actually, sir, I have this question because like some members of the CDC have also joined here. So I just wanted to convey this message to them that the whatever requirement is there from the industry aspect, that's for all included in our subject
Yes,
domain.
I had
So
seen the
the
syllabus.
yes,
Yes,
definitely, sir. So I think there is no point of worry for our students. Like whenever they are approaching or whenever they are facing any interview, they know that yes, they have the resources. They have been taught all the
absolutely.
resources
They have touched
required.
upon that issue. Yes,
Thank you
yes.
very much, sir. Thank you, sir.
Okay. So, is there any question from participants? Any more question? One request is there that
Yes.
whether these videos are available publicly or not, that you have shown.
I can share with you.
Okay. Okay.
The presentation and the videos together.
Okay. That would be great, sir. That would be great.
Because
Thank you.
ultimately, the more you share, the more it reaches to the next, those who
Yes.
require it. They will touch upon it, they will add on it and make it more beautiful.
Yes.
Sure, I will. I will.
Yes. So if you can share with us, we will be sharing with the participants.
Absolutely. Absolutely.
Okay. And okay, so we have come to the end of the show. And of course, before handing over the mic to once again Dr. Karmakar, I would like to announce that we have a quiz competition on Tuesday. And that will be online, and that will be a very innovative quiz competition because we will be using a platform called Mentimeter, which is free. and which doesn't require any kind of installation. So it's very easy to use. I am sharing the link with you for participating in the quiz competition, the Google Drive Google Form link. So if anyone is interested, please you can join us. Over to you, Dr. Karmakar.
First of all, I would like to say that it's a very beautiful session, and thank you, Dr. Basu, for sharing his knowledge and valuable time with us. And I know that it's a very short period of we just connected with you and you agreed on it, and so I would like to thank you. And here we have now I would request Dr. Manushi Devnath to please convey the vote of thanks of this program. Over to you, Dr. Devnath.
Thank you, Dr. Karmakar. On behalf of the Department of Geography, School of Basic Science, Basic and Applied Sciences, Adams University, it is immense pleasure to me to propose a vote of thanks to Dr. Basu, who has given immense information from basic to the higher level in this geoinformatics level. So it is really a good opportunity for us as well as for all the participants who are here. So we really thanks. We are expressing our heartfelt thanks to you. Heartfelt thanks to you. And we also giving our we are showing our thanks to our Chancellor Sir, Vice Chancellor Sir, and to Dean of SOBAS for giving us this opportunity to conduct this session. And and I'm also thankful to all of the members of the department for organizing this session. And lastly but not least, all of the attendees, thank you so much for expressing your interest to this webinar, and be live with us. And please stay tuned with us for next sessions and all other works which we are going to start in next few days. So now over to you, Dr. Karmakar. Thank you all.
So, sir, thank you once again, and I would like to thank all the participants for your patient presence here. And now I would like to call that I would like to put an end to this session. Thank you. Thank you, everybody.
Thanks, everybody. Thank you.